Hello there, ROS developers, and welcome to a new open class. Welcome everybody. We are going to have today open class number 164. So yeah, welcome everybody. Let me know please in the chat if sound is okay, if the image is okay, you can hear me properly. Yes, no. Let me know please here in the chat. And yeah, so today we are going to be talking about multithreading, which is a very important topic in ROS2. And more in particular, we are going to be checking about executors, different type of executors in ROS2, and in C++ in this case. Yeah, so we are going to see how to create a program in C++ using different types of executors and how this affects the flow of your program. So yeah, let's not lose any more time. I can see that everybody is saying that everything is good, all good, perfect. Great, then let's not lose any more time and let's get started. So I'm going to switch right now to my computer screen here. There we go. Then yeah, so let's go to the open class page as always. Here I have it. Here we have the chat, great. Then, yeah, so as always, we are going to start by forking the rosject, the class rosject. So, in case that you are new to these classes, this is very simple. All you have to do is to click on this button that you have right above the chat here, which says fork, and open the class rosject. So I'm going to click here myself. Then, by clicking here, this is going to create a copy of the rosject into your account. Yeah, first of all, let me mute here. And as you can see, it's also going to automatically bring you and open here the rosject page. Yeah, so here in the right side, you have the streaming panel with the live image, the chat also in case that you want to comment. I'm going to leave it here so that I can read your comments. And yeah, so it's going to create as well a copy of this rosject into your account so that you are going to have it forever. Yeah, not only for today's class, but you are going to be able to open it next week, next month, in case that you want to review it, check some notes, whatever. All right? Then let's all of us open the rosject. Yeah? And yeah, let's wait a few moments until the rosject also gets fully loaded. This usually takes some seconds, but it shouldn't take too much time to fully load. Then, meanwhile, this is loading. Let me tell you a couple of things. So, this class is based on Humble, first of all, the latest ROS2 release. And we are going to be covering here a small part of executors, of multithreading, yeah? So we are going to be covering the executors part, let's say, an introduction to executors in ROS2 with C++. But in case that you want to learn more about it, I will show this also later during the class. But in case that you want to get the complete image about ROS2 multithreading, I suggest you go to the course that we have recently updated, which is this ROS2 Basics in 5 days in Humble and in C++ in this case. Yeah, there is also the Python course, the Python version of this course, but today we are going to be working with C++. Yeah, so in this course you have all the knowledge related to ROS2 Basics, and of course also related to multithreading, which includes how to use executors and callback groups. Yeah, so for instance, callback groups we are not going to be covering or practicing with them on this open class. All right. Seth says, nice, I've been waiting for a course on Humble. Yeah. So we are starting to update our courses. So far, we have updated the ROS2 Basics one, which are the most important ones. But in the following weeks, months, we are going to be updating all the rest as well. All the ROS2 courses that we have, like ROS2 Navigation, ROS2 Control, ROS2 Manipulation, everything, we are going to update it to have it in ROS2 Humble. All right? Then, yeah, let me close all this. All right, so as you can see, my rosject has already loaded here, and once your rosject loads, you're going to see that it automatically opens here as well the notebook for the rosject. This is a Jupyter notebook where I have placed all the instructions in order to follow today's class. Yeah, so here I have placed some notes, some data, also some commands that we are going to be using, some pieces of code that also we are going to be using during today's class. All right, so all the important information, you can find it here in the notebook. Then yeah, so let's get started then. So the first thing that we are going to do in order to start today's class is to open the simulation. Okay, then in order to do this, we can run the following commands that you have here in the notebook in the how to launch the simulation section. And in order to execute these commands, the first thing that we need to do is to open a terminal. Yeah. Then in order to open a terminal, all you have to do is to click on this first icon that you have in the bottom menu here. I have already one open here. Let me close all of them. Yeah. Then by clicking here, this is going to open a new empty Linux terminal, Linux shell, where you can type the commands. All right. Then in order to launch the simulation, we are going to have to run these two. So you can copy them directly here from the notebook, for instance, with Control-C, and paste them into the terminal with Control-V. Yeah. Then first of all, we are going to source the ROS2 workspace here. And second, we are going to execute this ROS2 launch command, which is going to start the simulation. Yeah. So let's execute it. And here we can see all the output of the program, and after some seconds, the simulation is going to load, and it should automatically open here into your rosject a gazebo window. Here you are. Yeah, so here it has automatically opened this gazebo window, and here is where we are going to be able to see the simulation. As you can see, it's a very cool simulation here with a Japanese themed bar or restaurant, or I don't know. Yeah, and then we have three small robots here, each one of a different color, which are very convenient for demonstrating this multi-threading topic. Okay, so today we are not going to be using all the simulation in its full potential, sorry, but yeah. So here we have the simulation loaded. And we are ready to start with the class, with the practice. Yeah. So let me know, have you been able to load the rosject properly? Also, have you been able to load the simulation properly? Yes, no? Yeah, perfect. Okay, then let's start. So let's start with the practice. All right. Then the first thing that we are going to do is to create a package here where we are going to place all the different programs that we are going to create during today's class. All right. Then before actually creating the package and everything, let me suggest you to open the code editor. Yeah, the code editor, you can open it by clicking on this second button here, which says Code Editor. Yeah, I'm going to click here myself, and this is going to open another window, which is going to provide you a graphical environment in order to visualize all the workspaces, files, everything that you have inside the rosject. Okay. Juan David says, I have a question. Sorry if you answered it before. It is Humble? Yes. This project is based in Humble. Juan David. Yes. All right. Then let's create our package. So in order to create our new package, you have all the commands here as well in the notebook. Then let's go to our terminal, and here we are going to open a second terminal. Yeah. So in this first one, we have the simulation running. We don't want to close it. So we are going to leave it here running, and we are going to open a new terminal by clicking on this @ icon here, so that we get a new blank terminal. There we go. All right, now here, let's execute the commands. So first of all, we are going to go inside the ROS2 workspace src. Then we are going to execute the ROS2 package create command. Yeah, ROS2 package create. This is the name of the package, Executors exercises package, and we are going to add a couple of dependencies to our package. Yeah, rclcpp and nav messages. All right, so let's execute this command. There we go. And now we are going to go back to the root of the workspace, yeah, to our ROS2 workspace, execute call compiled to build our new package. There it goes. And when it finishes building, we source our workspace. Yeah? Okay. Then, yeah, so if you go inside the src folder of your workspace, you are going to see this new package, Executors exercises packages. Yeah? Also, you have this boxbot and animated actors TC, which are packages related to the simulation. Okay, don't worry about them. The package that we are going to be working with today is the Executors exercises package. Okay, then also you can see this through the code editor. Yeah, so you can come here to the ROS2 workspace, go inside the src folder, and here you are going to find these packages. Yeah, here we have the Executors package, which right now it's basically empty. Yeah, we have not placed any code or anything inside it yet. Yes? Okay. Then let's go with executors in ROS2. So basically, executors, summarizing, allow you to manage how your programs are executed. Yeah? Then you're going to find three basic types of executors, yeah, in ROS2, which are the single-threaded executor, the multi-threaded executor, and finally the static single-threaded executor. Yeah, these are the three basic types of executors that you can use in ROS2. So the single-threaded executor, as the name itself says, it's going to execute your programs in one single thread. Yeah? The multi-threaded executor is going to, well, it allows your program, your nodes, to be executed on multiple threads at the same time. Yeah? And finally, the static single-threaded executor, it's a version of the single-threaded executor, so it also allows, it also executes your programs in one single thread, but the difference with respect to the single-threaded executor is that the static one doesn't allow to modify your program on runtime. Yeah, so your program must initialize everything. Yeah, the timers, the publishers, the subscribers of your node, everything has to be initialized when the program starts. Yeah, so everything has to be defined, let's say, on the program initialization. Yeah, you cannot modify your program on runtime. This is why it's named static. Yeah, and it's more efficient, let's say, in terms of CPU usage than the single-threaded. Yeah, and in the same note, the single-threaded executor is more efficient than the multi-threaded executor. Yeah. So the multi-threaded executor is the one that requires more resources, of course, because it's working and it's using multiple threads. Yeah? Okay. Then let's start with some example codes so that we can get used to, we can see how to work with executors in ROS2 with C++. Okay? Then here we have our first example code that we are going to run. And this first example is basically going to use a single-threaded executor running a node with two callback functions. Yeah? Then let's come here to the code editor and create a new file inside the src folder. And we are going to name this file like this: executor example 3 cpp. Okay? Then let's come here to our executors package, and inside the src folder, you can right click on this folder and then select the new file option. Yeah? And now here you can insert the name of the new file that you want to create. In my case, in our case, it's going to be executor underscore example underscore 3.cpp. Yeah? We click on OK, and then the new file is created. As you can see, it automatically opens here also. And right now it's empty. Yeah? Because we have just created this file. Then the next thing is that we are going to copy the code here from the notebook, all this code. We are going to select everything, copy it, and paste it here into the code editor. Okay? There we go. Yeah, so now I have my code here in the file. Yeah? Then let's have a quick look at this code. Yeah? So let's see what we are doing here. Then, first of all, as always, we have some include. So we are including here the odometry message, for instance, from the nav messages package. We are including RCL CPP also, in order to be able to program ROS with C++. Yeah. Then, what else? So we are declaring a first class here, which is named odom subscriber. Yeah. So we declare a class, odom subscriber, which inherits from the node class. Then here we have the constructor of our class. And inside the constructor here we are creating a subscriber. Yeah? We are creating a subscriber for the odom topic name. Yeah, this odom topic name comes from this attribute here, odom topic name, which is defined later. It's defined down here, and it's here. Yeah, this is the topic that we are going to subscribe to, box underscore bot underscore 1 odom. Yeah, this topic basically it's going to it provides the odometry data of one of the robots. The first one, robot number 1, which in this case it's this one, the blue one. Yeah. So this topic here contains the odometry information of the robot 1. Okay? Then we are creating our first class, which is declaring a subscriber. So I'm not going to, I'm not going to explain about all these details of the code, what is a subscriber, what are all these things. Yeah, this is not the topic of this class, okay? If you are lost on these subjects, yeah, in what is a subscriber, what is a timer, etc., you should come here to the ROS2 basics course, where all this is explained. Yeah, in this course you are going to get all this basic knowledge required. Yeah, so here I'm not going to explain all of this, but I'm going to focus only on the executors thing. Okay. All right. So I declare a subscriber for the odometry topic, and here I have the callback function. So in the callback function, basically what I am doing is to print a message into the terminal here with the information related to the position of the robot. Yeah, the X, Y, and Z coordinates of the robot. I am printing them like this into the console. Okay. Then I am defining here a second class, which is named slow timer. Then inside this second class, I am defining a timer object. Yeah, a timer object which is going to be executed each 500 milliseconds. So basically, it's going to be executed 2 times per second. Yeah. And then this timer has also a callback function attached to it, which basically what's going to do is to print a tick message also into the console. Okay? Yeah? All right. Yeah, so far so good. I don't see any messages there. Are you following? Yes. Perfect. Good. Okay, great. All right, then what else? Yeah, so here we have, then we have the main function here, finally. And in the main function, we are, here, we are creating the first node. Yeah, so we are creating an instance of the first class, providing the attribute name. Yeah, so we are creating an instance of the first class, this Odom subscriber class. Yeah, which is named Odom subs node, okay? And then we create an instance of the second class, the slow timer class, yeah, slow timer class. We create an instance of the slow timer class named slow timer node, okay? Here we are printing a couple of log messages, nothing too important, and then here is where we are creating our executor, yeah? So we are creating our executor, which in this case, it's of the type single-threaded executor. Yeah? So this is how you create a single-threaded executor in ROS2. Yeah? If you want to create a multi-threaded, then you're going to change here, instead of single-threaded executor, this would be multi-threaded executor, okay? We will see it later. Then once we have created our executor, we add the nodes to the executor, yeah? So here we are adding the first node, which is the Odom subs node, yeah? And then we add to the executor the second node, yeah? You can add as many nodes as you want to an executor. And you can also add one single node, yeah? That depends on how you structure your program, etc., yeah? Then, in this case, we are adding two nodes to the executor, okay? Remember, the first node contains the odometry subscriber, and the second node contains the timer, okay? And then, after adding the nodes, we basically spin our executor so that it's going to keep executing, yeah? It's going to keep executing and spinning until somebody kills this executor. Okay? All right. Then, now that we have seen our code, let's compile it, yeah? So, in order to compile it, first of all, we need to add some lines to the cmakelist.txt file, okay? So, let me just copy them here from the notebook. And we need to open here the cmakelist.txt file and add these lines here at the end of the file, okay? Oops. Here. Yeah? So, what we are doing here is to generate an executable, yeah, named like this, a binary file, let's say, an executable, named like this, executor example3 node, yeah, and we are generating this executable from this CPP source file, yeah, executor example3, which is the file that we have just created. Yeah, so from this file, we are generating an executable, we are adding some dependencies to our executable, and we install the executable into our workspace. Okay? Then, once we have updated our cmakelist file, we can compile. Yeah, so here in the notebook, it's not indicated, but after updating the cmakelist file, what you have to do is to compile, okay? Remember always that you want to compile, you have to go to the root of the workspace. Yeah, here in ROS2 workspace. Don't compile inside the src folder. Yeah, never. You compile in the root folder of your workspace, which is, in our case, this one, okay? So from here, call build. See, here it is compiling. So with callcom build, you are compiling the whole workspace. Okay, as you can see, it's compiling all the packages from the workspace. The thing is that all of these packages are already compiled, so it takes no time. So the one that it's actually building, it's this one, Executors exercises package. Yeah. Let's wait until it fully compiles. Now there is, yeah, there it goes. So, yeah, and important, when it finishes building, remember to always sort your workspace, okay? Then, also you can build only this package for this case, yeah? So if you want, you can run this alternative command, callcom build, then -- packages select, and then you place the name of the package that you want to compile. Yeah, so that you don't compile all the packages of the workspace, but only the ones that you are interested in. In this case, the one that we want to compile, it's only this one, so we can also run this command, and with this command, we are going to only compile this package. Okay? Emilio says, I have an error. What error do you have, Emilio? In animated actors package. User src executors package src executors example 3 cpp line 4 1 error does not name a type. I also have a compile error. Yeah, so you shouldn't have a compilation error. If starting CMake error, CMake list 27. Yeah, so probably if you are getting errors on compilation, there are two possibilities. Okay? First of all, you have copy-pasted these lines from the notebook wrong. Okay? Yeah? So one possibility is that you have copy-pasted these lines wrong, and the other possibility is that you have copy-pasted these lines wrong. The code. Maybe you are missing some part of the code, you didn't copy it properly, okay? So if your compilation is failing, is because of one of these two reasons, okay? So go back to the notebook and check that you have actually copied and pasted properly this to the CMake list file and this code to the CPP script, okay? Ryan says, look, you have to select the text from the prompt. Don't use copy. Yeah. So it inserts invalid characters into the file. Yeah. In some cases, we have to investigate this properly. But in some cases, if you use this tool to copy the code, sometimes it, depending on your setup, it inserts some weird characters. Yeah. So I suggest maybe to just. If you use this tool to copy paste, remove everything and copy it like this by manually selecting all the code like this and then copy and paste. Okay? Ryan is right. I had to delete some invalid characters. Nuria Pujol. Yeah. So maybe this was your case. Yeah. So let's copy paste the code by selecting it like this. Yeah. Let's try to avoid for now to use this copy button. Okay, all right. Then yeah, so after compiling, we can run the code with the following command here. So let's copy it again from the notebook and paste it here. ROS2 run executors exercises package executor example 3 node. So I'm going to run this here. We can see some odometry messages. Yeah, and then after some seconds, we start getting these tick messages. Yeah. So we get this tick message and one odometry message, tick message and one odometry message, tick message and one odometry message. Yeah. So this odometry message, this line here, which prints the odometry message, as you can guess, it's the one that is being generated by the first node. Yeah, the one that contains the subscriber for the odometry callback. And of course, this tick line is the one generated by the second node. Yeah, by the slow timer node, the one that contains the timer callback. Okay? Yeah, so this is the tick line and this is the odometry line. Then what is actually happening here? Let's try to do an experiment. Yeah, so let's leave our program running here, and let's open another shell. Yeah, a third one here. Now in this third shell, we are going to run this teleop twist keyboard program that you have right here in the notes in your notebook. Yeah, so you can copy the command here from the notebook as well and paste it here into the third terminal. Yeah, there we go. So this teleop twist keyboard program is a ROS2 node that you can use to send velocities to the robot. Yeah. In this case, as you can see, we are sending velocities to the robot number 1. Okay. So if we open here the gazebo simulation, we are going to be controlling this robot here. Yeah, the blue one. Then let me send some velocities. Yeah. Also, in order to be able to move the robot, you can use these keys here. Yeah. This is like a keypad, and you can use these keys to control the robot. Yeah. So, for instance, with the key I, you are going to move it forward. With comma, you are going to move it backward. With J, you are going to turn to the left. Okay, and so on. Then, yeah. So let's see one thing. So currently we are getting here the positions of our robot, right? We are getting the values of the position in the X coordinate, Y coordinate, and Z coordinate. Yeah. So the current position in the X-axis, for instance, is 0.5 meters. Yeah, more or less. Then let's try to move now a little bit our robot here. Let me go back to the teleop keyboard here. I'm going to move it forward a little bit here. There we go. And stop. Yeah? And go back to the odometry program. So what can we see here? Yeah, well, actually, it has moved here to 0.85. Yeah, actually, let me keep it like this, because otherwise it's a bit weird. So I'm going to keep it like this. Let me make it smaller like this, and move it back again using the keyboard. There we go. Let me move it back again. Sorry. I need the focus here. There we go. So let's move it back again. Yeah, and go back to our code. Okay, so what can we see here in the odometry? We can see that the value of the X coordinate has jumped from 0.85, right, to 0.4 in just one reading. Yeah. So what happens with all the values that are in between these? Yeah, we have lost this information, right? And this, in robotics, can be a huge problem. Yeah, so you cannot. So in this case, of course, this is just a silly example, so it's not that important. But when you are working with real life robots, industrial robots, you cannot lose information. Yeah. Specifically when working with, let's say, laser readings, when you need all this information so that your robot reacts to the environment, yeah? You cannot allow yourself to lose all this information, like we have done here, right? So, can somebody tell me why this information is being lost? Do you know why this information is being lost? Because of the timer delay, says Emilio Hernandez. Yes. Callback queue is full, says Dinesh. Yes, that's also correct. Because there are 2 threads, Florencio. And no, that's not correct. Actually, the problem is that there is one single thread, yeah? Sorry. So, what is happening here? Let's just stop already the program, yeah? We can stop it already, the keyboard teleop and our program. The simulation, you can keep it running, yeah? So, what is happening here? Basically, let's go back to the program, yeah? So, we have 2 nodes. We have first the node that is publishing the odometry data, yes, which is this one, Odom subscriber, and we have the node which is publishing this tick message, the one that contains the timer, yeah? Then what is happening? The problem here is that we are using a single-threaded executor, right? So there is only. So this program is only using one thread to execute both callbacks, right? Then what is happening is that this callback, the timer callback here, it has an sleep inside it. See? So inside the callback of the timer, we have an sleep here. This sleep is pausing, let's say, the program for this wait time. Yeah, the wait time we have defined it here. Yeah. It's 3 seconds. Yeah. So this timer callback is going to be executed one time every 3 seconds. And it's going to publish this tick message. Then meanwhile, the program is sleeping here. Yes, in this timer callback, I am losing all the information that is being published into the odometry. Yes? Why? Because I have one single thread, so the odometry callback has to wait until this callback finishes, until the timer callback finishes to execute. Right? Then, meanwhile, my program is sleeping here, all the information from the odometry is lost. This is why we had this super big jump in the odometry data. Yes? Yes? So I had this value here in the x-axis, and then until the next odometry, until the timer callback finishes sleeping, and I get a new reading of the odometry, which is this one, all the information in between is lost. Yeah? Do you understand? Do you see the problem here? Yeah. Yes. Okay. So what can we do to overcome this issue? Well, what we can do is to use a multi-threaded executor, right? So we can say, we can tell our program, hey, don't worry, you are allowed to use multiple threads, Okay, so you are not limited to one single thread, but you can use multiple threads. Yeah. So in order to do this, you mean because the DDS queue has only 10 elements? During the sleep time, the buffer overflowed. Yeah, so this is another thing, let's say. So you are talking about the queue size of the this is the queue size, okay, of the subscriber, which in this case it's 10. And this is defining the quality of service of this subscriber, but I'm not going to get into that much detail, okay, because that's, yeah. Yeah, okay, so Ryan is also mentioning about this, so I see that you are familiar with also the queue size. So yes, in this case, the queue size here it's of 10, yeah? Okay, yeah, very well. So I didn't want to get into this detail because I want to leave it on the surface. Yeah, but yes, exactly. Very well. Okay, so I see that you are already quite familiar with ROS2. All right, then yeah. So let's change our code now to use a multi-threaded executor, okay? Then here you have, so let's move to section 3 here, where basically we can create a new program here, or we can just modify the one that we have already, yes? Which maybe it's going to be more interesting, yeah? So here you have the full code, but actually everything is the same, yeah? All the code is the same, except the final part here, where we are going to declare a multi-threaded executor. Yes? So let's come to our code here, yeah, and change this line number 58, from single-threaded executor to multi-threaded executor. Okay? Only this. And let's recompile. Yeah? So let me come here and recompile. Colcon build. Yeah, again, I am compiling everything. Yeah, but let's just do it the right way. Yeah, which is to compile only the package that I am interested in. Not that it's going to go faster, but it's more convenient in this case. There we go. Lujiang says, shouldn't I see 10 ODOM callback messages, I guess, between ticks? No. In this case, no, Lujiang. You see only one. Yeah, so Ryan is, I think, is answering you. He says, in single-threaded, it's only serviced once per RCL CPP spin. The rest of the time, it's sleeping. Yeah, exactly. So this line that you see here, at the end, when we are spinning the executor, so every time that the executor spins, it is forcing the callbacks to be executed, yeah? So actually it's publishing one message from the odometry callback, and it's doing one loop, let's say, of the timer callback. But the problem is that it's getting stuck in the timer callback because of this sleep. Yes? All right, then let's source. And let's run again our program here. There we go. Okay. All right. So now, let me stop it because otherwise you don't see it, yeah? So we still have the tick messages, see? The difference is that between tick and tick, I am getting many odometry readings, yes? See, so here I have a tick message, then after 3 seconds I'm going to get the next one, but in between I'm getting all the odometry messages. So I am not losing any information, see? Here I have the next one. Yes? So now, for instance, we can see that the value of the odometry in the x coordinate is 0.4. Yeah? So again, if we do the same experiment, I'm going to move the robot a little bit to the front here. Let me put it small for a moment so that I can see the robot. Let me move it a bit to the front, like this, and the stop. Okay. And now, if I come back here, yes, so I can see all the process between, yeah, so here it's when the x value was 0.4, then I have started moving the robot, and you can see gradually how the value, yes, let me stop it because otherwise the program keeps moving me down, yeah. Oh, I lost it. Okay, then let me do it one more time, just to illustrate this properly. Yes, so let me do the movement backwards this time. There we go. Stop, stop, and stop. There we go. Okay, so now, yeah, let's go back to the beginning. Yeah, so we can see here when the x value was 0.87, then I start moving the robot backwards, and you can see how gradually, yes, the value is decreasing as I am moving the robot backward, yeah? But all the information in between the initial and the final position, I get it, I don't lose it, yes? So I can see all the values in between, yes? Here I already stop the robot again, and it stabilizes again, yeah? And this, so here, in this case, the only difference to the program that we have done, as you have seen, is one line, yeah? So the only thing that we change it is one line. We change it from using a single-threaded executor to using a multi-threaded executor, yeah? Does it make sense to you? Do you get the point here? Yes, says Sajat. Okay. Also Jeff. Okay, perfect. Yeah, then yeah, so let's run an additional example, okay? Let's run a final extra example, which is to run two different executors, okay? So let's create a new CPP file in this case, which we are going to name like this, executor example for single-threaded. Yeah, so let me come here to the SRC folder of the package again, right-click, new file, and create the new file, okay? Then once we have the file created, we come to the code, select everything, copy it, and paste it. Okay? Then what are we doing here? Again, all the classes and the code, everything is the same, okay? So the only difference is down here in the main, because we are creating two single-threaded executors. In this case, they are static, okay? But it doesn't matter. You can create them also single. Without being static, it's going to be the same, yeah? So we are creating two executors here. Executor and executor 2. And then I am adding one node to each executor. Yeah? So what do you think is going to happen here? By the way, let me update. Meanwhile, I'm going to update here the code to compile my new program. But what do you think is going to happen there? So example 4 node. I think the name of the node is this one. Let me copy it from here. Yeah. So I'm going to say node, and the file is example 4 single threaded. Yep. And then we put the name as well here and here. Yeah. And then compile. So let me compile my code, colcon build, packages, select, oops, there we go. And let me get the name of my package, which is Executors exercises package. Yeah. Okay. Emilio says, executor 2 doesn't need a spin method call. Okay, that's a point. That's a point. That's a valid point, yeah. Here we are only spinning one. Okay. Let's see what happens. So, yeah, that's an interesting take, okay? That's an interesting take. The problem is that there is another problem with this code which goes before that one. But yeah, so just by having a look at the code, one thing that comes to mind is that, hey, executor 2 doesn't need to spin. All right. In any case, the code is going to compile, but I'm going to compile it now, adding also executor 2 spin. Okay, so this compiles, source install setup bash. This compiles without errors, okay, first of all. Then let's add as well a spin for executor 2. Executor 2 spin. There we go. And let's recompile. All right, almost there. Okay, there we go. Source. And let's run it, yeah? So let's try to run our program and let's see what happens. So here we have it. Let's run it. Okay, so we get the odometry data, but all right, can you see something strange with this output? Can you notice something? That it's not working as it should? So we get the odometry is working properly, yeah? So probably if I move the robot, the values are going to be updated, right? Let's see. Let me move it forward a little bit, stop. There we go. Yeah, so the values are updated properly. The problem here is that only the odometry is being executed, right? So where are the tick messages? The call timer is never executed, says Florencio. We don't get the tick comment, obviously. Yes. So only one node is being executed, only the first one, yes? So executor 2 is not being executed, yeah? And this is why? Well, very simple. Actually, this is because you can only have one single executor per binary file, per executable, yes? So all this code is generating an executable, right? An executable named like this, yes? Then per each executable, you can only have one executor, okay? You cannot have multiple executors. So in this case, executor 1 is being executed, but executor 2 is being ignored, okay? So this is basically the issue, something extra so that you know, okay? Then, yeah, so these are some of the, this is a brief introduction to executors, okay? So you have learned a little bit how to use executors, how to incorporate executors into your programs, okay? The syntax in C++, also some interesting differences between single-threaded executors and multi-threaded executors, and what problems, what issues can arise from using one executor or another, yeah? Then there is many more things to learn here related to multi-threading. So for instance, for multi-threaded executors, we have said and we have seen that they allowed your code to be executed using multiple threads, right? But then there is also, you can also control how your callbacks are executed, yeah? So in this case, we have two callbacks. We have the callback for the odometry subscriber and the callback for the timer, yeah? Then you can also control how these callbacks are executed. In this case, this would be done using callback groups, okay? And yeah, so there is many more to learn here. Unfortunately, we don't have time to learn everything here. So yeah, as I said at the beginning of the class, in case that you want to learn more, see more examples, learn about callback groups, or get some of this basic knowledge related to ROS2, you can come here to the ROS2 Basics in 5 days humble course. Okay, we have the C++, but we have also the Python version. Okay. So both versions, also in Python, you can have a look at the how executors and callback groups are managed. Okay, and yeah, so for my part, I'm going to leave it here. Let me read these last messages. Kvan, second executor is not ignored. Spin function is blocking mode executor to spin. Never get called, yeah? If spin returns, then simply program exits. Yeah, right. So the program is, you could use while true executor 1 spin sum. Okay. Okay. Still have the same problem of the wait blocking all odometry. Well, yeah, not actually, because you are going to have, yeah, so what you are saying, okay, now I understand, yeah. So what you are saying is that so This is the first executor, which is spinning on the odometry, of course. Then if we get out of this spin, of the first spin, we are going to access the second executor. Yes, that is right, yeah. However, keep in mind that it's not going, so this is not actually true, this sentence, this last sentence, because executor 2 has only added the timer node. Yeah, so we would only have the tick, right? So in this case, we have odometry node added to executor 1 and odometry node added to executor 2. Yeah, so we don't have both nodes added to one single executor. Yeah, so the scenario is different. Okay. In any case, I can see also with the spin sum and some things here, but I wouldn't recommend using multiple executors in one single program. Yeah, in general terms, I would say that it's not a good idea. Okay. Then also, you can answer this at the end of the class. I got pulled away a couple times for work issues. We should have the rosject in our construct account. And can walk through the notebook later? Yes. Yes, Jeff. So you are going to have a copy of this rosject in your account forever. You can open it next week, next month, whenever you want. Okay? So yes, the answer is yes. You are going to be able to access it later. All right, then, yeah, so I'm going to leave it here. Thanks a lot for being here with me during this hour. I hope that you enjoyed it. I hope that you have learned something new. And yeah, so I will see you again next Tuesday with the next open class. And as always, take care and keep pushing your ROS learning. Bye-bye.